Hi everyone, thank you so very much for having me today. I'm really glad to be able to take you with me to these faraway ice and snow regions of the world. Through my work, I get to travel to the Arctic, to Antarctica, to the Himalayas, to Alaska, to wherever there is ice and snow, to better understand how these magnificent glaciers react to climate change. And I decided to put the takeaway message of my talk right away. In order to avoid the very worst consequences of the melting of the cryosphere to the melting of ice and snow, we need to do our utmost to keep global temperatures below 1.5 degrees, or we will trigger irreversible consequences that will be very, very difficult to stop. I'm just back from an expedition that took place in the heart of the Arctic on the archipelago of Svalbard. And what we got to experience there, which you can see on the picture, was absolutely mind-blowing. The Arctic is reacting much faster to climate change than we were expecting. Before traveling to these faraway regions, I started my career in the Alps, which is where I'm speaking to you from right now. I'm currently in the French Alps, and this is where I grew up. But I actually started studying the glaciers in Switzerland at the beginning of my studies. And here is the very first glacier I studied. Its name is the Glacier du Trient, just at the border between France and Switzerland. And this glacier, more than 130 years ago, was actually extremely important for the economy of the region. At the time, the meltwater, the fresh water coming from the glacier every summer, was being carried by a very sophisticated network of canals to bring this fresh water to the nearby villages and nearby valleys. Also, the ice from the glacier itself was actually mined by the local inhabitants, and this ice was being sent to faraway cities, to Paris, Marseille, and other cities in Switzerland this time. And this was used to preserve food. And this goes to show that already more than 130 years ago, glaciers, these beautiful mountain glaciers, were really important for the economy of the region. When I got to study Trient, it looked very different. It was back in 2010, and the glacier was just the shadow of itself. And the two pictures are actually taken from the same place. And this shows you that glaciers are pretty simple elements. They are made from the compaction of snow that becomes ice eventually. And this ice reacts very quickly to climate changes. This is why glaciers help us to make the invisible visible. When the temperatures change, when the CO2 concentrations in the atmosphere change as well, glaciers react very quickly. They are some of the best barometers of climate changes we have on Earth. So why should we care about these beautiful mountain glaciers? Well, for several reasons. First of all, because most of the fresh water we have on Earth is actually stored in these beautiful glaciers. This fresh water is actually used for drinking, obviously, but also for sanitation, for irrigation of all crops, also to produce hydroelectricity. And in the Alps, this water is also being used to cool down nuclear power plants. And during the last big heat wave we had here in France back in 2003, the discharge of a river like the Rhone River was maintained during the summer months only because of the glaciers. Without these glaciers, we would have had a discharge 40% lower. And this goes to show how important these glaciers are. Glaciers are also very important for local economies. You know, winter activities in the Alps, for example, are very important. In France, they generate up to 9 billion euros every year, employ 120,000 workers only during the summer months. And again, this is directly connected to snow and ice we have here. When glaciers melt and snow also becomes scarcer, it creates a lot of hazards from landslides, rockfalls. Also, glaciers are currently collapsing in the European Alps. But taken all together, all these beautiful mountain glaciers, all the 200,000 glaciers we have on Earth contribute to sea level rise when they melt. And together they can increase sea levels globally by about 40 centimeters. And this is not taking into account the big ice sheets we have on Earth. This is only mountain glaciers. So as you can see, these glaciers have huge importance in our daily lives. But glaciers are only the tip of the iceberg. If we take into account the ice we find in the atmosphere, the snow, the sea ice, ice connected to the ocean, the frozen grounds, permafrost, or also river and lake ice, together they make something that we call the cryosphere. And today we are losing our cryosphere. No matter which segment of the cryosphere you look at, this is currently being affected by our activities. And whether you live close to the polar regions, in high altitude environments or low latitude environments, or along the equator, no one is immune to the current loss of cryosphere. The consequences of the melting, of the thawing, of the collapse of the cryosphere are absolutely major. So let's take a look at what is happening to the different parts of the cryosphere. For example, we can start with sea ice. And sea ice is this crust of ice that is covering the polar oceans. And this is a video showing you what's happening up north in the Arctic. And this is a region that I am extremely passionate about because our future is directly connected to the future of the Arctic. Simply because there is a lot of ice in the Arctic, and most of this ice is either on land, in mountain glaciers, in the ice sheet of Greenland, but also covering partly the Arctic Ocean. And this is what you can see here. This kind of white cloud covering the Arctic Ocean is Arctic sea ice. It plays a major role globally because Arctic sea ice helps to stabilize climate. Very simply because sea ice is white, and all these white surfaces on Earth are able to reflect solar radiation back into space. And Arctic sea ice is in contact with a warming ocean and also air that is getting warmer. And therefore, we are currently losing summer sea ice in the Arctic, and also during the winter months, sea ice retreats dramatically. We have lost, in terms of sea ice extent, the size of a country like India in the Arctic in the past 40 years. So these changes are really major, and it is unfortunately already too late to prevent the disappearance of summer sea ice in the Arctic. And the consequences for us in mid-latitude environments will be dramatic. And we are already feeling the consequences of the retreating summer sea ice in the Arctic. It will create more weather extremes in our latitudes. It will also increase temperatures during every month of the year in France here, for example. So sea ice is very important. We also have another element of the cryosphere, which is permafrost. Permafrost is the frozen soil we find in high altitude environments or high latitude environments. And permafrost is very important when you think that more than 60% of Arctic infrastructure is built on permafrost soil, is built on this frozen soil. This is not just living buildings, houses, like you can see here on the picture. This is actually a picture of a village in Alaska that had to be evacuated because the permafrost underneath the village is thawing too quickly. But stuff built on permafrost is also pipelines, is also storage units where we store oil and gas. So there is a lot of fragility, a lot of weaknesses in our current infrastructure in the Arctic. But also when permafrost thaws, it releases greenhouse gases. And the more we increase temperatures on Earth, the more permafrost thaws and the more greenhouse gases permafrost emits. This is methane and also CO2. And the more CO2 and methane is being emitted by permafrost, the less greenhouse gases we can emit ourselves to remain within the targets of the Paris Agreement. When we look at the polar oceans this time, the polar oceans play a very important role in our daily lives. First of all, the polar oceans absorb most of the CO2 we emit. And because they're so efficient, they actually become more and more acidic. The more CO2 we emit, the more CO2 they absorb, the more acidic they become. And we know that these tiny animals, these pteropods that you can see on the picture here, that have this skeleton are being directly put in contact with these more and more corrosive waters that is directly affecting them and affecting the rest of the marine food chain in the polar regions. So this is something that is very, very hard to reverse. If we decrease our emissions, if we help to slow down the current warming, we will slow down the acidification of the polar oceans. But if we go beyond 1.5 degrees, the process will become irreversible over very long time scales. We're talking about hundreds of thousands of years. And now let's move on to the biggest ice masses on Earth that I got to visit quite a few times during my career. And these are the ice sheets of Greenland and Antarctica. Just to give you an idea of scale, if the island of Greenland were to completely lose its ice, it would increase sea levels globally by 6 to 7 meters. I mean, 6 to 7 meters. This is absolutely major. There is a lot of ice in Greenland. But if we look at the Antarctic ice sheets close to the South Pole, around the South Pole, if this continent were to lose its ice completely, it would increase sea levels globally by 58 meters. So these ice sheets are of prime importance, and they are being dramatically affected by climate change at the moment. We are seeing that both ice sheets are so much more fragile than we were expecting. And even if we were to lose a tiny portion of Greenland, a tiny portion of Antarctica, the consequences would be dramatic. And some of my colleagues are already saying that parts of Greenland and parts of Antarctica might have already reached their tipping point. But again, if we want to preserve as much of Antarctica, as much of Greenland as possible, we have to keep global temperatures below 1.5 degrees. Otherwise, it will be very difficult to prevent the collapse of both ice sheets. And we know that these ice sheets have already collapsed in the past. And what has happened before can definitely happen again. So what I want to really insist on, as you can understand, is this notion of temperature thresholds. When it comes to the cryosphere, when it comes to mountain glaciers, snow, sea ice, permafrost, ice sheets, or the polar oceans, we have to keep global temperatures below 1.5 degrees, because whatever happens beyond 1.5 will be irreversible. You know, if I had a magic wand and if I was able to suck all the CO2 from the atmosphere beyond 1.5 degrees, it will not make a huge difference for the ice sheets, for example, because when we push the first domino, it is very, very difficult to stop the collapse of our big ice sheets. And this would lead to a multi-meter sea level rise by the end of the century. And imagine, think about the future generations. They will be impacted for centuries and millennia to come. So how do we do this? Luckily, we still have a window to act. It's not too late to prevent this. And that's not me telling you that, it is the IPCC. The IPCC says we can still prevent this. We can still keep global temperatures below 1.5 degrees. We have the funds, we have the brains, we have the technologies, we have the will to do that. Some people have more will than others, that's for sure, but the window of action is definitely there. We have a couple of years to prevent global temperatures from going beyond 1.5 degrees. And the roadmap is simple, but of course extremely challenging. It is to reduce our emissions in half by 2030. So my question to you now is, what are we doing this year? What are we doing this month? What are we doing today to follow this plan? How are we going to keep global temperatures below 1.5 degrees? We don't have the choice. We have to make this work. So let's do it together. Thank you so very much, and good luck with the rest of the event. Thank you.